Hi students, today I'm going to explain and do some problems on C configuration and especially the H parameter model of C configuration. In theory, I explain what is the H parameter model and what this H parameter model helpful for analysis of the transistor configurations. Basically, in order to finding some transistor characteristics, the characteristic parameters like like AI, RI, AB, R naught. So the current gain, and input impedance, voltage gain, and output admittance or output impedance, all these characteristic parameters have been evaluated from the H parameter model. So in this problematics, we'll take this problem and finding the H parameter model equations to determine these transistor characteristic parameters, especially in this uh, like a approximate model and a exact model. Let us see that using exact analysis and approximate analysis, how to find out these four parameters. Let us try to understand this problem. Let us see. Let me read. This a common emitter amplifier is drawn by voltage source of internal resistance Rs 800 ohm. So it is 800 ohm. And RL is equal to 1000 ohm means 1 kilo ohm. The H parameters are HIE 1 kilo ohm. Actually, it is converted from latex to this one. It will change that symbol. 1 kilo ohm. And HRE is equal to 2 into 10 to the power of minus 4. HFE is equal to 50. HOE is equal to 25 microampere per volt. Determine AI, RI, AV, R0 using exact analysis and approximate analysis. We know that C amplifier, it is basically C amplifier, transistor C configuration. So in this transistor C configuration, VI, VCC, RC, the output voltage, input voltage. This can be converted into the transistor model. Basically, transistor model can be converted into H parameter model. We will take only this transistor can be modeled into H parameter that can be drawn like in a H parameter model. We can draw this like this diagram. Basically, the input voltage, the input resistance, input impedance HIE, HOE, like HOE, RE, HFE, IB, HRE. So basically, this is the V1 V output voltage. This is output current IC. There is input current IB. Sorry, input current IB. So this H parameter model, it is only for the transistor. So if you want to draw the entire amplifier, we can connect to base resistor, like if it is voltage divided by as R1 parallel R2 and load resistor RL here. So all those things. So but in this case, this is the figure represents the H parameter model for model for C configuration, transistor C, the transistor C configuration. So from this, already all those things we explained right now in this C amplifier topic. So directly we can consider the formulas, how to derive this, how to determine this current gain, input impedance, voltage gain. Like so, let us see the given data first. Given data. The given data is RS is 800 ohm, RL is equal to 1 kilo ohm, HIE is equal to 1 kilo ohm, device input impedance parameter 1 kilo ohm, HRE is equal to 2 into 10 to the power of minus 4, HFE is equal to forward current gain in common emitter amplifier is equal to 50, HOE is equal to 25 into 10 to the power of minus 6 ampere per volts. So determine the volt current gain. AI is equal to formula HFE for actually HFE by 1 plus HO into RL for general analysis. If it is common emitter configuration, we can put second subscript like HFE, HOE into RL. So substitute this one, we get minus HFE is equal to 50 divided by 1 plus, as we take that HOE. HOE is what is given 25. HOE like 25 into 10 to the power of minus 6. RL is given 1 kilo. Let us take that 1 kilo. 1 into 10 to the power of 3. So minus 50 divided by 3 cancel. Remaining minus 3 is there. 25 into 10 to the power of minus 3 means 0.25. 1 plus 0.25 is 1 plus 0.25. 1.025. 1.025. So we will get that answer minus 48.78. The current gain for C amplifier. Actually, this is HFE is also current gain. The forward current gain HFE in the given data 50. The device parameter forward current gain is 50. But when we connecting in an amplifier, C configuration amplifier, that if you substitute in the formula, it will be reduced by minus 48.78. So by considering HOE into RL, then that 50 can be modified into in the exact analysis AI is equal to minus 48.78. Similarly, next parameter is input impedance. It is current gain. Next, input impedance. Input impedance formula HRI actually so input impedance RI for the device is HIE plus HRE current gain AI into RL. Already we know that current gain we just now we found, just now we calculated AI, so we can substitute that current gain in this input impedance. actual input impedance of the transistor in the given data. The H parameter model input impedance HI is equal to 1 kilo ohm, 1 kilo plus HRE is equal to 2 into 10 to the power of minus 4 into AI. Take this one from this here. HIE 1 kilo ohm plus HRE 2 into 10 to the power of minus 4 into AI minus 48.78 into RL 1 kilo ohm. By substituting all these things, 1 kilo, 2 into 10 to the power of minus 4, here it is kilo, 10 to the power of minus 4 cancel, 10 power minus 1 is there, minus 48.78 into 0.1. So here it is 10 power minus 1 is there, into multiplied by 2. So it will be modified to 2 is 0.2 into minus 48.78, you will get minus 9.75. Then it will be subtracted with 1k minus 1k is nothing but 1000. 1000 minus 9.75 will get 990. Approximately 990. Actually, this is input impedance of the device without considering the external circuits. If you consider external circuit, it is not given in the problem. If it is considered like input impedance, base resistance, or some voltage divider bias resistance R1 and R2 external network, so then that will be considered. If it is considered that one, then actual input impedance is for a voltage divider bias R1 parallel, R2 parallel, RID, this one. But in the problem it is not given, so directly this is the input impedance. Then voltage gain. Voltage gain AV is equal to whatever we found current gain multiplied by RL divided by RI, where RI is the input impedance of all parameters, device input impedance, and in parallel with R1 and R2. If it is not given in the problem R1 and R2, RID is the RI only. So input impedance. Current gain already we found. Just take that current gain minus 48.778 into RL 1 kilo ohm divided by RI. Just now we found RI 990. So we just calculate that one. 1 kilo 1000 divided by 990 minus 48.78 into 1.01. 48.78 into 1.01, approximately minus 49.26. That one is the voltage gain. Next parameter, output impedance. So in order to find out the output impedance, we must first find out the admittance of the transistor parameter. So HOE minus HFE into HRE divided by HIE. HOE 25 into 10 to the power of minus 6 minus HFE, like HFE is nothing but 50 into HRE, 2 into 10 to the power of minus 4 divided by HIE. HIE is equal to 1 kilo ohm, 10 to the power of 3. 25 in minus 20 to the power of minus 6. Now, this 1000, if you take the upper side, 10 to the power of minus 650 into 2, 100 అవుతుంది. So, 10 to the power 1 into 10 to the power of 10 square, 10 to the power of minus 7. 25 into 10 to the power of minus 6 minus 10 into 10 to the power of minus 6. So if we subtract it, 15 into 10 to the power of minus 6 and power minus 6. If you calculate this one, output impedance of the device is equal to 1 by admittance. So 1 by means 10 power positive 6 divided by 15. Then we can calculate 1 by 15, 0.06 into 10 to the power of 6. So we can 60 kilo ohm, or output impedance is 60 kilo ohm. And the problem is given using exact analysis and approximate analysis also. What happened in the approximate analysis? In the transistor parameter, finding the approximate analysis, we consider some parameters for the approximate analysis. Approximate analysis. In the approximate analysis, so we can consider that HOE into RL approximately equal to 0.1, because HOE value is 25 into 10 to the power of minus 6. It is very small. So in the formula, the current gain, there is a denominator term HOE into RL term. This HOE already it is very small, 25 into 10 to the power of minus 6 multiplied by RL. So it will become also, it is very small when compared to approximately equal to always less than 0.1. So then approximately equal to less than 0.1. So it is neglected. So when it is neglected, the current gain formula actually AI is equal to minus HFE by 1 plus HOE into RL. When it is this one denominator term HOE into RL is neglected, then it will approximately equal to minus HFE. That is represented by approximate analysis. Current gain, then voltage gain, input impedance. Basically, device input impedance RID is equal to HIE plus HRE AI into RL. Okay. So this one, when we multiply this HRE, so it is also approximately equal to this one. This multiplication of this HRE AI into RL. HRE 2 into 10 to the power of minus 4 AI into RL is also negligible. Then we can consider only HIE. So this RID is equal to HIE. Even if you substitute external resistance RI, R1 parallel, R2 parallel, RID is also approximately equal to RID, which is approximately equal to HIE. Because R1, R2, so when R1, R2 parallel, it is R1, R2 is very large compared with this RID. So in parallel, the smallest value is RID, so which is equal to HIE. Then output voltage, output current is equal to output impedance, R0 is equal to, basically it is infinite with the device, and R0 R0 with external circuit, RL parallel with infinite. When in parallel, any large value in parallel with RL, then in resultant is in RL. So R0 is equal to directly RL is in the problem. So in this given problem, when we substitute in the approximate analysis, that AI is equal to minus HFE. The minus HFE in the given problem, the forward current gain is equal to 50 minus 50, approximately 50. Exact analysis is minus 48 point something, 48.78. And similarly, input impedance Ri is equal to HIE. What is HIE here? In the given problem, HIE is equal to 1 kilo ohm. So actually, in the exact analysis, you will get a 990. But in approximate analysis, you will get same 1 kilo ohm, means 1000 ohm, approximately 1000. And input impedance is over. Voltage gain. I forgot to voltage gain. Voltage gain is equal to minus HFE into RL by RI, where RI nothing but HIE. So minus 50 into RL 1 kilo ohm by HIE 1 kilo ohm. Cancel. Voltage gain is also minus 50. And finally, that output impedance R0 is equal to RL is equal to, RL is given in the problem. RL is given in the problem. RL is equal to 1 kilo ohm. So 1 kilo ohm. Then compare with this parameters. 50 will get 48.78. In the approximate analysis, RI 1000 ohm will get 990 ohms. Third one, AV 49.26 in exact analysis, but approximately 50. And output voltage resistance 60 kilo ohm, but in a 60 kilo ohm output impedance. But in this case, we'll get RL is equal to R0 is equal to RL 1 kilo ohm. This one. In this way, we can consider this exact analysis and approximate analysis. So we just remember that formulas. AI is equal to minus HFE 1 plus HY into RL. Input impedance RI is equal to HIE plus HRE into AI into RL. And voltage gain AV is equal to minus HFE RL by RI. And output impedance nothing but output admittance nothing but reciprocal of output impedance is equal to reciprocal of output admittance. Then admittance formula you will substitute it, then you will get the answer. So in this way we will find out the H parameter model, characteristic parameters of voltage gain, current gain, input impedance, output impedance of a given C amplifier using H parameter analysis, especially exact analysis and approximate analysis. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.